My PPT screen is displaying all of you.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, good. So this is our summary of review of what we have learned up to third lesson. That lesson in lesson one we describes why R is very important in today life. We will familiar with the technology, then we can do with the huge data set and make our graphic and statistical analysis in a good way and present it in an excellent way. So our publication and thesis can be accepted easily. Then I discussed structure of R softwares. R software works in four window, window 1, window 2, and window 3, and window 4s. In window 1, we write commands. In window 2, R is the mind of R software. And window 3 consoles where your command display are run and our error are also appears in window 3. And window 4, as you see that graphic are displays, function are packages are present, and you can see that the package are already installed or third-party package, which is types of packages. Packages are two types that are already installed, we say that, and then you have to install that as third-party package is not present. For any function, you need package. If your package is not present, or could not do anything. So package is important for any functions. Then I discuss with you installation of package. You can install your packages to install dot command, and also you can install package from window 4. Packages are installed, then the step is activation of that packages. So you have to activate all your packages so that this can be your function can be performed. Then I show you and give you a commands activation of all package in one go. With single run command, you can activate all your packages, and these are activated in your window force, and now you can install, you can do your functions easily. And in lesson 2, we learned that we can make working directory. I said in my previous lecture, the working directory is the connection between our softwares and with the computers. If working directory is good, then you can import your file, you can export your files. If your working directory is not good and you have made a long working directory, then error chances will be more. If you have space between the folders names and your file name, will give some problem in during exporting of data and also in working directory. Then we learned how we can import and export files in R. We can import files through CSV, through Excel file, and similarly we can export our file our after analysis in Excel formats or CSV. And also I show you how can we print out and text format, we can also export our data file. Then we learned that how can we import our graphics in PDF, in PNG, and then we see that how we can combine different graphic in one PDF file. So graphic should be good, looking good, and in journal also have do not sufficient space for individual graphics. They say you present different graphics in one page. So your message and that your parameters are showing similar patterns of your results. So it's a good to combine these graphics in one PDF file or present it one page. So your message, your main message, which you are conveying through your thesis draft or your paper draft, it will be easy and acceptable to journals, editor, and reviewers. So in the last, I discussed with you how can you save your whole sessions. We are working with the long sessions. We have different commands and we do our initial analysis and initial data setting. So how we can save that so that the in long sessions some error come out sometime you delete dot and other things, so your all session could be disturbed. So it's a good working in R2, 3 R files where initial working and then your graphic workings and your statistical working. So do in different graph, and after saving, you can retrieve R session easily in any file. So this is the brief review of up to that we have learned R softwares. And I discussed that these are the very basic things you must know that so you can move forwards. So we are up to here, and today we will discuss the structure of data. Structure of data is very, very important. If your data structure is good, then R will perform it. And data structure has two parts. That's it, dependent variables and independent variables. When you export data in R do not understand that what which you are treatment variables and which you are parameters. So what affects the treatment variable which you affect you are checking on different parameters. So I said that in irrigations, nitrogen rate, mulches in this data, these are our treatment variables whose effect we are checking on plant height, number of balls, and different plant or soil parameters. So you give structure of data to R. R do not understand that what your parameters are treatment variable, what your parameters are say dependent variables. So you must know your data, and data has only two this structure, dependent or independent variable. Treatment variables are the measured variables. So you must give this conditions to your data. And in initial, I said that people do different mistakes, and this is one major mistake. If you do not give proper structure to our softwares, our firm will confuse. It will not make good graphics, and he could not perform statistical analysis of your data. So you must start define structure of your data, and that we will discuss in today's lesson. And then when we will perform different analysis commands, we will use head, tail, summary, columns, names, how we can display it in our software, and how we can know which columns names our data has. Then it is subsetting in R by category and values. In category, we will see that we have treatment, irrigation. For example, we have two levels. Factors have always two levels. So if we skip irrigation and normal, two type of irrigations, and we want to do analysis with only one normal irrigation. I want to perform analysis one type of in within the one irrigations. So how can I made this thing in ours? And then second one is the values. My some data in some parameters, some values are higher from literature. So these are not a good value. All values are 1, 2, and 3, and 1 my value is coming 100. So you see, it's maybe sometime personal mistake or some other mistake. So I do not want that this value should be present in my data. And in normal practices, some people modify it or change it. But in R, you can give command to R, so R will skip that value. So R will remove that values from your data, and you can perform your analysis without any manual change in your data. Then we will learn that column selections. We want some parameters are we collected all our raw data, but we want that some column should be present in our data and some column should not be present in our data. So how we can selection of column. And then is the deletion. You want like selection, you can also delete some column you do not want that it should be present in my data. So in R we can delete different columns. And then we will discuss change of column name. You want to change column, I said all your data should be a underline organic underscore matters. So in graphic I do not want like this underscore. So I want full name of parameters. So you can change column name in our software, not in data file. You do not need to change your things in data files. And same column addition, you want to multiply some column or you want to add in new column with a so with equations, or you make some calculation in your data and you want that this column should be added in my data. So through arm functions you can add addition in column. And rearrangement of levels of treatment. And you are treatment, sometimes we say that the control and different treatment are present. So we want a specific arrangement in x-axis in our graphic. So we how we can arrange arrangements of levels of treatment in our graph without making any editing in our data. And then is the binding of column and row of different data set. You have two data set, you have different, you have collected two, you have two data sheets, and you want that the I want to bind one column of that data set into first data set. So you can bind columns and rows of different data set, so in through our functions. So this is the today lessons which we are discussing. I'm going to discuss. This is very important for your statistical analysis and graphic. These command will repeatedly use. Instead, you will see in next two-day lesson, these all command are basic commands, and that will be used in statistical analysis and graphic presentations. So anybody have question after that?
I have some question, Dr. Saab.
Yes,
Usually, there are some fields, especially, for example, in agriculture, the agronomy.
yes,
We are sort of the research is somehow like cause and effect.
yes.
The effect of mulch, the effect of soil nitrogen, the effect of I mean pesticide, something like that. I am from plant breeding. So somehow my research is mostly focused on the molecular mechanisms or even though I also we have the how to say the productivity data, for example, different yield parameters. But usually we check different types of varieties, different types of cultivars, land races, for example, and we just check their performance irrespective of applying any a fertilizer or something like that. We only want to check genetically which one is superior. So how to use this command, and for example this lesson 3 can help me to use my data or arrange my data in that way without having any this how to say the cause and effect type of parameters.
Yes, yes, Dr. Nasrullah, all your data we can discuss your data, and all these command will be helpful as we will proceed. You will see that in our softwares. So you can also we can perform. This is different models. So we will see which model will we apply your data, and we will do modification to this structure of data. So we can do accordingly. So it depend data to data. When we will do your statistical analysis, we will show your screen and we will do step accordingly as your data will needed.
Okay, okay, okay.
So
Thank you, Dr. Sir.
thank you. So that's a that command basically will remove your manual working in data. If I will show you data files, I will make some question with you. So in practice, what people do, so you can understand today lessons. So we will we will change that name so our original file should not be disturbed. Okay. In normal practice, Dr. Nasrullah, if I want that I do not need control in that data set, what should I do? In practice, what we will do? I do not
Sorry, Dr.
need.
Okay,
Okay, I
can
repeat
you
my.
repeat the question? Can you repeat the question, Dr.
Yeah,
Sir, again?
yeah. Data is displaying on your screen. My data sheet.
Yes, yes, yes. It's shared.
Okay. If I want that control should not be present in my data set, what should I do in normal practice?
You mean if control is not present in the data?
I want to do analysis without control in my data. What should I do?
Uh, to be honest, I'm speechless on this in this regard because mostly whenever I did some experiment, I always use some
No, no,
controls.
no, 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 no. Its control is my question is not experiment. If I do
Okay.
not want one level, control or other mulches. So you can see plastic mulch. I do not want to wish include my plastic mulch in my data analysis. What should I do? I want to make graphic without plastic mulch. What I should
Then
do
you have to
with
delete
that if
delete this
it's
column. So just delete
oh
this
good.
column.
Okay, good. So I should have to make a new sheet. Yeah,
Yeah, yeah,
it
yeah.
mean you mean.
Keep the original one here, and then you can maybe like make a new sheet.
Okay. Any other body can suggest me a solution of that. I do not want to include plastic mulch in my data. I want to make graphic and statistical things. What should I do? Some any other body can suggest me. What is solution of that? Can anybody suggest me solutions? I do not wish to work with the plastic mulch. Anybody?
If there is any command in R, I can tell R to skip this column.
Yes,
I mean,
yes.
without deleting it.
Yes, without deleting in, yeah, we can skip it in R. So we do not need, as Dr. Nasrullah said, we should delete it and make a new files. So in R, you just skip it. Your original file will be present. You do not need any manual thing to deal with it.
Okay,
And
so we have command for this. Oh, that's good.
yeah, that's the way, that's the beauty of R. So you do not delete to anything. So you just have to silent it in R. So you just have dealing. My other question is that my in plant height, I have some values which are above than I said that above 100 centimeters. But literature is saying that the way your plant height should not be exceed from 100. So what should I do now? Some my values, all my values are under below, but 2 and 3 plants are showing this that my values are above 100. So literature, all literature is supporting me that see my things should be below 100. So 2 and 3 values are out of that range. What should deal with this data?
We will give the command to R that value should not be exceeded to than 100.
Yes, and our we can that, but what in routine what do we do with if we do not know R, then what is the practice and what our students do with that data?
They will change the date.
We will change it individually.
We usually
Normally
do the
we
partition,
normally we
divide
use
the values.
the SCODs and cortosis in Excel sheet, and we change the
Yeah,
values accordingly. We
yeah,
check the normality just.
yeah. We that's a way we can check normality, but in practice, what people do in especially when they have like that things. Okay, sir, I do not. If I do not want the yield column in my data in normal routine, what should I do? If I do not know R, if yield I do not want yield column in my data, what should I do?
So the
We
same
can
as just you're talking about the mulch, just mask it by giving some command.
Okay, no, oh, we do not know R. What do we in normal practice?
we will
We do not.
we will delete the
Yes.
column.
Yes, we should delete the column and we will make a new file. So
Yes,
count how many files are making manually.
yes.
So
We will save it, then we will make another file, then we will make another file.
yeah, at the end we do not know which one was
Yeah,
the original file.
it happens, sir.
Yeah, it's normal practice. This is happened that we
Yes,
delete or modify or something
yeah,
with like that, and we make a new files.
yeah,
So at the end, we do not know which one was the original file. We confused, and our supervisor are also confused.
yeah,
So very much big confusions dealing with data.
yes, sir.
Yeah, this is okay. My other question is that I have this data, and similarly, I have some other data I have collected it. So I have two sheets. What should I do? This sheet is present and the other sheet is also present with me. So what should I do? This have original data one and this have original data two. What should we do in normal practice? We have two data sheets and we want to combine the column of these two data sheet. I want two column from other data sheet to put in this sheet. What should I do? What we should do in normal practice without R? We do not know R.
So we will
So
insert a new column in it.
yes, and then we'll then the same will be make a new file.
Yes.
Yes, then we will make a new file. So
Yes.
we
Yes.
yeah, yes, count on how many files are
Yeah,
making we are. So we have and we combine two different rows. We have two data set and we will want to combine two and three rows of different data set into that set. And then will be the same answer that we will make again a new file.
Time consuming.
Yeah,
Troubling us.
that's a time consuming, that is a confusion, big confusions. So we have many multiple sheets and we will confuse ourselves, our supervisors, and in papers and thesis are a lot of confusions, making different sheets and different. So all R can do all these things without any manual editing. All we can make you skip the can by categories, skip by values, and can combine different columns and combine different rows and delete these columns. So we will do this. We will see these things in our softwares. So anybody have confusion with it? So then I said the structure of data. So you understand here is that Uh, Dr. Nasrullah, can you explain the dependent or independent variable? Some students are present, maybe new for researcher in MSc. So they have big confusion with that. So that's a big problem. So if you do not define or what you are dependent variable, what you are independent variables. So you cannot proceed statistical analysis, your graphic will not make. I said that you clear this point and you arrange your data. I showing you that screen, that's irrigation, mulches, nitrogen rate and replications. So this should be present first. So your data should be accordingly arranged. So Dr. Nasrullah, please explain them dependent or independent variable or treatment or measured variables parameters. So student are present so they can understand that plant breeding is very with dealing with statistical analysis. So please little bit explain them
Actually,
dependent and independent variables.
actually, Dr. Saab, when we deal the cause and effect type of research,
Mm,
we have variables. Dependent
yes,
variable is whose value keep on changing in response of changing the, you know,
yes,
for example, if here we see the, if you change the, for example, change the nitrogen, change the, for example, change the, maybe you can change phosphorus or potassium something. So in response of changing the nitrogen, changing the phosphorus, it will affect the yield. So yield is dependent on the, on what? On nitrogen, on phosphorus and these. So in that case, yield will be dependent, and nitrogen, potassium, and something, maybe some hormones using your, that will be independent variables. As far as we do in our data.
yeah,
Uh,
yeah,
um,
that's good. Yeah, that's also you clear that the parameters you measured, that's a dependent variables, and that
yeah,
you
yeah.
are not going to measure, that's are independent variables, that are your treatment variables. What effects you are going to check on other parameter. So please clear this concept, dependent or independent variables. These are very crucial, as I say repeatedly, that in statistical and graphics. So that's variables that show on x-axis What will be these parameters?
Dr. Saab, repeat it again.
In x-axis, which parameters should be present, dependent or independent?
Independent.
Yes.
If you put in a better, yeah.
Yeah, in x-axis, parameter are present are always independent, and on y-axis, parameters present, these will be always dependent
Dependent.
parameters. Yeah, this will be always dependent parameter. So student, especially MSc student which are involved in our training, so they must understand which parameters are dependent and which parameters are independent. So their data sheet and all these things should be very, very clear with that. So dependent and independent. So we have to give structure to our R softwares.
Dr. Saab, are you listening
Yes.
to me?
Yes, yes.
Um, Actually, I got the real sense of your data, but I'm just a little bit confused at 2 point. For example, if you see in the irrigation normal, and skip normal. So I don't know what does here skip means, and in the replication 1 2 3 and then 1 2 3. Can you be little bit explain it here? What does the skip mean, and what does the how did you use? I mean the replication 1 2 3.
Yeah, that's a arrangement is not problem here. You I will show again you it's you can see that I have two levels, normal and skip irrigation. That's a two irrigation is the factors, and that's our two level, normal and skip irrigations. And in mulches I have four levels: control, plastic mulch, rice straw, and sawdust. And in nitrogen 0, 75 and 150, and then are the replications. So this data is arranged like that with normal, control, 0 nitrogen, and first replication. Normal, control, 0 and 2 replication. Normal, control, 0 and 3 replication. And likewise skip and that. This is arranged in with control mulches. Keeping dependent on mulches. So we have arranged all this data. So these we have three factors, and within three factors, irrigation has two levels, mulches have four levels, and nitrogen has also three levels and also three replication. So this data is arranged like that. Dr. Nasrullah, clear you?
Dr. Saab, clear. And the
Okay,
rest
good.
plan heights, all these are parameters need
These
to be
all
measured.
are these are all measured parameters. So up to that we have not in this data is so
Okay.
okay. So now we will proceed with our today lessons in our softwares. So all of you are okay with set working directory?
Yes,
Yeah,
sir.
no problem in working directory.
Okay, so we have make working directory that we discussed yesterday, and now we are going to import our data of soil parameters, so soil sheets. So we will work today with the soil data. And you can see that R has imported this data in his system, though you can see in window 2, the data is successfully imported. Now we have to, this is start here from that data underscore, this is data frames. Data frame means that your data should be arranged in column and row, in rows. So you can see that you give this command. If data is arranged, it's okay, but you always try to run this command. Sometimes it's give errors if do not run that command, data dot frame. And this is the data file that I imported. This is the start is equal to before I write the file name. So our file name is data underscore soil. So this I put in data frame. And then third step, I said you the structure of data is important. So we will check what is the structure of our data, what R shows us. So You can see what structure is appearing of our data. What structure Dr. Nasrullah is saying that R is what structure present us. So what is saying is irrigation, mulches, nitrogen and replication. What types of it saying that?
So there are total 72 observation and 10 variables.
Yeah.
And if you can see here, for example,
Irrigations, what is saying that what is CHR? It's saying that it's a characters. So
okay,
normal wordings are says that I know that it is characters. In mulch, it's also is a name, control, plastic mulch and different stuff. So it's saying that it's also character, and nitrogen is integer. So 00771 is the
but
full
why?
number.
But why here? If you see in the character in irrigation, in the inverted comma, there are 3 types normal, 3 types control, and only 1 type skip. Why not skip is 3 times?
No, it's a not showing. It's a showing that we have imported. It will show in next step what is the level of. So it's a giving name just. So
Okay.
he read it that the normal and skip. So it will showing all things, but it's showing that these are the name, and I know that these are the characters and mulches. So it's same. It's saying that these are also characters, and nitrogen rate these are numbers, full number. So these are saying these are integers, and replication, so 1 2 3, so it's also integers in a structure. But in
Mhm.
organic matter you say that it's a points value, so it's number, all other things it's saying that all these are numbers. But your four first your irrigation, mulches and nitrogen rates, and so the irrigation and mulches these are characters, and nitrogens or replication it's saying that it's integers. So if I perform this data further with statistical analysis and graphic, so how can perform it? The structure is not but I said these 2 types of structure and 2 types things should be in your data structure. One should be factors and other should be numbers. If these 2 things are not present, so how can I make with characters? How can I multiply character with something? So I cannot do with characters anything. So this is very important steps you clear it. If you confusion at that stage, please ask. If your data structure is not correct, you cannot do anything in R. So many times we when beginners want to make graphic and put their data, and they also imported their data, but when they will give commands, so or make a very not good graphics. So because we do not define our which are our treatment variables, which are our measured variables, dependent and independent variable. Though this step is very important, like directory and important of file. This is the third step in my. That's very important. If you do not understand your data, or you not give a right structure to your data file will not work in our softwares. What, Mohit Ali, what you have learned from this? What is mean by structure?
I have a problem with my network, so I
Okay,
had to
okay.
I had to close and open again. So I missed this part.
Okay. So we are dealing with the structure of data. We imported our files in ours, and then we will run this command structure data underscore. So this structure has display before us, and R is saying that irrigation is characters, mulches is characters, nitrogen is integers, and replication is integers. But in data set, I said that these are my factors. These are my independent variables which I am going to check effect of these things on my other parameter. So if I proceed with these things, I could not make any graphics. I could not do any statistical analysis. So what should I do now?
So, Dr. Saab, anything shown by number will be independent variable.
But how we can, if we proceed, my question is that if we proceed with this data, R will not do anything. Dr. Moid Ali, you
Yes, so I have to
Uh,
change the characters from the variables.
Yes. So first point is that you have to change your independent variable to factors. So your structure become right and you can proceed further. So any other person can repeat. That is very, very important points. So can Sayed Adil Hussain Shah sir, please can you repeat this thing?
Structure of data format should be in factors and numbers. Our
Yes, which
independent variables should be factors and dependent variables in numbers.
yes, these should be numbers. So we can make graphics and we can do statistical analysis.
Yes.
So okay, good. Any other person can Farina Shaheen, can you please repeat the structures of data? What should be structure of data? Dr. Farina Shaheen, can you please repeat this point? Any other person? Any other person can?
So I will explain that in this structure we will make the independent variable the character which can be changed by us, and the independent variable dependent variable should be in integers numbers, so that it can be we can make graphs of it.
Yes, so this is very, very important points. Your structure should be right to proceed further. So if your structure is not right, you cannot do anything in our software. So you must know the structure of your data, and your structure should be comprises of two things. First should be factors and other should be numbers. All your independent variable should be factors and your dependent variable should be numbers. Now we will see how we can change our structure. So we know that our structure is not right. So we have to correct this. So this is our data file, data underscore soil. And then within the data underscore soil, what I want, this is within that is the functions. Now what thing I want that I want to change irrigation into factors and factors into irrigation. So I want that this irrigations column should be changed into factors, and like this mulches should be converted into factors, and nitrogen underscore rates should also be converted into nitrogen, and replication is also converted into factors. So all things I want to convert, I can convert it through factors. I will run these commands. So now you can see what is our revise now. Now, Dr. Nasrullah, your question is in say, clear. You say and there something is repeated, normal is repeated many times. So here your structure is, now its structure is okay.
Yeah, you
Factors,
can see how.
yeah, it's now showing that the irrigation has 2 levels. Your mulches have 4 levels. Your nitrogen rate has 3 levels, and your irrigation has also 3 levels. So now you can see that R has made a right structure for you, and your dependent variable are converted into factors, and your independent variables are into numbers. So here is your structures. So first of all, you will do import your file and run will data frame commands, and then you will see structure of your data, and then convert your structure into factors and into numbers. That's important for you for any statistical analysis, for any graphical analysis. So these two steps are very important. So in all analysis, these two steps should be follow. Okay. Up to that, all things are clear with you. So we will proceed. All other things are very simple, but this thing I take time, so you must clear. So this thing, then you can proceed with further. So next is the structures. We did structures up to now. We want head command, head tail underscore, we want to see, we will run that command, and you can see that R has show first six rows. First 6 rows nitrogens, replic organic matters, and what all parameter first 6 rows. So these are on the tops. So if you want, if you have very long data which has many rows, and you can see that six and you want to that you imported right file or not. So you will use this command, head command. And then then you can see the summary commands. We have do with this before in previous lesson. So with this command is important. I will show you that you can see how we can use summary command in different statistical analysis and in our different graphical work. So this is simple summary commands. And this is the summary of our whole data set. If we want to just summary of first any column, so you can see $sign. This will show your column, which column you want to do. So you can see that columns names. And you can say these are different columns. And if I want to see the summary of one column, data underscore soil, and this is a $sign, then your column window will be open. So I want to see the summary of only one organic matters. So you can see that it show me summary of only one parameters. That's a minimum value, maximum value. We usually used this minimum and maximum value in our graphic. So through these summary commands, we can define our y-axis limit. So we can see summary of one parameters. So this is again the columns name command. So this is, you can see columns name which your data set have columns, and you can see that these are our data set and these are their columns. And similarly, we can see level of what levels irrigation have. So you can see that data irrigation has 2 levels, normal and skip irrigations. So you can see that. So Dr. Nasrullah, can you repeat these commands? Head, summary, columns, names, level. Dr. Nasrullah, sir. Hello.
Yes, Dr. Saab. As you see from the command for, can you go upward? Yeah.
Yes.
From here, after structuring the data and putting in the frame, what we have to do, because we have in the data file, we have multiple columns. For example, the first column may represent the irrigation, the second may represent the nitrogen level, the third one like this. So from this command, for example, the head data soil, then we can how to say analyze column by column the data. What I perceived from this instruction.
Yes. Yes, we can see that if we have long data set, we could see that we imported correct data or not. So we can see with these head functions, and we can see that this correct data file is imported in our software. So you can see with that.
I was confused whether the head mean the head title of the column, or what does head mean?
Head mean is the top 6 rows of your data.
Top
Top 6
six
row.
rows.
Yes. So you can see that your data is correct. So you can match this file with your original data file. So you can see that this file is correct. That's I am going to work. Sometimes I say that's a very big file, many GR data. So sometime in importing, you can make some mistake. So through this, you can see correct file is imported in our softwares. So you can see that.
So you mean, Dr. Saab, that when we upload a single file with the single spreadsheet and we have multiple rows, so we divide these rows into groups. For example, you share here the six, the
No, no,
top.
your data contains all rows, but you just want to see upper side of your data. Sometimes you see that you have imported correct data. So we are
Okay.
saying the 6 rows means that your file is correct. It not means any grouping. Your all data is same. So you are just seeing upper side of that. If somebody is present, so you want say, yeah. So this data file, so you see that upper 6 rows or I imported data is correct or not correct. So that's the purpose of that command.
Okay. I get.
Okay. Then these summary functions. What summary function tell us, Dr. Nasrullah sir?
Summary function, just like, for example, we run the descriptive statistics, just like a very simple command we perform first here. So it will show you the summary command, for example, the sometimes say the minimum value and the maximum value. For example, when we draw it in the graph x and y, so it shows the limit of the y. I mean the maximum limit and the minimum limit.
Yes. And then the column names. What advantage of column names command? So what you see in column names?
I mean, by the column name, we can, how to say, analyze the data column by column. For example, maybe the first column name is, how to say, the nitrogen, and maybe the second one is the. I'm little bit confused about this column name. Yeah.
Okay,
I'm
yeah,
confused about.
that's okay. That's a column names that your data contains. What names of your columns that data have. So it's a just purpose that so you can see you do not have to open your data file and see what column I should have work. I am going to work. I am going to make a graphic. So just you can paste. You can take name of that correct column name and put it in for your graphics. So you want to working and what. So I said that in as in organic matters, we want to take summary of only organic matter. So I can take that's name and put it in my data underscore soil $sign and organic matters. So it will give me summary of. So I do not have to open again and again my data file. So I can see my all column names in our software with this command. So all column name are present here. So I do not any need to open that file again. So we
Okay,
can
so
do
the
that.
beauty is that we can analyze the data, I mean, factor, how to say, parameter by parameter.
Yeah, we can parameters by parameters. We can see our all things in data in our software. We do not need to open our data file again and again. So that's the
Oh,
main purpose of that.
okay.
Then is the levels, and you can see here is the name of columns, but here's levels are not appearing. So with these levels, you can check how many levels your factor has. And so in data underscore soil $sign irrigations $sign, remember the $sign is the column. It will show your columns, and data underscore is our file data file. And when I write $sign, it means I want to do with that columns irrigation. So I want to see that columns names show me only column names, but I want to see that how many irrigation factors have level. So I can see it with this. So you can see that it show me that your irrigation has two normals and skip irrigations levels. So again, I do not need to open my data file and I see that which irrigation has two levels. Irrigation factor has two levels. So I can see it in my R softwares. So any question up to that? So we are moving toward the subsetting where I said that I do not need to any deletions. If I want to skip anything, I want to deal with only one thing. So we are moving with subsettings up to that. So any questions? Any confusions in these simple? These are simple commands, but these are very useful commands. You will see in our graphic and statistical analysis. That's how these are important.
Sir, I have a question regarding the parameters. Sir, if our some parameters are in figure in letters instead of numbers, just like in wheat, we have scored about the scars and on status. So how can we make the graphs and figures of that?
You have means.
Dr. Sab, actually, he's talking about the qualitative data. Quantitative
Okay.
data is qualitative.
Yeah,
You know,
yeah.
green is G, black is B,
Yeah,
and
yeah,
something
that's
like that.
yeah. That's some different commands. We will deal with you will show us your data. So these are some different. So we are currently dealing with quantitative data, as doctor say. That's we can deal with it. We will show you.
Okay,
That's
sir. Okay.
how. Oh, okay. So next step is the subsetting. I said the subsetting is that you want in irrigation said that we have two levels, normal and skip irrigations, but I want to work only with normal irrigations. So I do not want to do in skip irrigations. So I show you one time, 1 minute, one graphic. So at this point will be clear to you. My screen is displaying this statistical table, is displaying all to you.
Yeah, Dr. Sab.
So, okay, this table is made from that data that we are doing with. So we have two irrigations, normal irrigation and deficit irrigations, and then we have mulches, control, plastic mulch, rice straw, sawdust. Now, my question is that's why I ask you in a data file that I want only to work in normal irrigations. And deficit irrigation I want differently work. I want separately work in normal irrigation and deficit irrigations. I want to do statistical analysis differently. So how can I do that? You said that in manual practice we delete or we take only one data set and do all analysis with it, and then we do second irrigations and would do analysis separately. So that's this analysis is done accordingly. Then we did our stat in normal irrigation separately, and we did statistic in deficit irrigation separately. So this is the file. I want to make a new files in R with normal irrigation only and want to make a separate file for deficit irrigations separately. So you understand my point with this table? How do I statistical analysis differently in a normal irrigation and I did in deficit irrigation?
Oh, no, Dr. Sab, sorry, I didn't get it.
Okay. So that's a we did analysis in normal irrigation separately. So we did separate and we did in skip irrigation or deficit irrigation analysis separately. So we can do not do analysis combinedly. So we need a normal irrigation file and we will need deficit irrigation file. Both files should not be mixed. We make two files from single file. You got my point? Anybody got my point? So you make
Yes.
one
Yes.
Yes, Mohit Ali, you got my point?
Yes, I get your point. Yes, I get your point. But I think we need specific command for this.
Yeah, that's we are doing that. We are doing instead. So now you can see that in our software. So we are going to make a new file in our data underscore normal. So this function is subset data underscore soil, and in irrigation I want only normal. So we have two levels, and you can see in window 3 we have normal and skip irrigation. So we want only normal irrigation. So I will run this command and then you will clear. I run these commands and now you can see in window 2 what now what is the change between original file and new file. What is the change in window 2?
Half observations are coming.
So R has make a new file in AdSense with normal irrigation only. So I show you this also. You can see it's so our file contain. Now you can see that in window only your normal file data is present. Your skip file data has removed by R.
Yeah. Now it's quite clear.
You can see that only normal irrigation data is present in your R has removed. R has make a new file. So you can see that you make this manually by make one file, two file, and three files. But in R we are doing this with commands. So our original file is safe. No effect on it. No manual editing. No manual deletion. And no, it's a lot of work when you have to delete normal irrigation or skip irrigation from your files and making new files. So it's a very confusion and it's a very big work. But in R, you can skip anything you want. That is the greatness of ours. Ours can deal it with commands. So you can skip anything, you can silent anything, you can remove anything, and that's. Anybody have confusion with this?
It's clear now, Dr. Sab, to me.
Okay, anyway. Sayed Adil Hussain Shah Sahab, have you clear with this?
Yes, sir, I have cleared.
So no manual no deletion from today.
Yes, sir.
Okay, good, good. And Mohit Ali, you have got that point?
Yes, I get this point.
Oh,
I can
good.
see the normal only. The
Yeah,
normal
normal one.
irrigation with yes,
Yeah, no skip
with half
irrigation
of the
in that.
operations.
Yeah, that's it.
36 only.
Yeah, this is with just a single line commands. You have removed others level of irrigation. So no manual working is required now. Anything Dr. Farina Shaheen and another body can explain what I did. So these are important points. So I want you must clear these points. Yes, Dr. Fahim, can you please explain this? Dr. Fahim, can you repeat?
Yeah, sure. I think we want to analyze only the normal irrigation and we want to remove the skip irrigation. So we have deleted the skip irrigation by command and we have checked only the normal irrigation. And the experiment was split instead of 70 observation to 36 observation. But my question is that the second file I want to save a separate file with 36 observation, only the normal irrigation. This file should save automatic in my R folder or I need to add some other command to save this particular file.
No, there's a automatical save. Your question is good, but you have to change its name. So your original file should be remain in same. Before is equal to, you have to give it some different name from your original file. You can see that our original file name is data underscore soil, but here we have changed before equal to data underscore normal. So when you will use that file, R will know that it contain only normal data. But if you will use a data underscore soil, it has contained both data set. I will show this you again. So that's a question is very important, Dr. Fahim. So in it, and you can see that in our original file, both data is present, normal and skip irrigations. Dr. Nasrullah, you got that point? That's important points.
Sorry, Dr. Saab, there was a little bit internet interruption at this time.
Okay, okay. So you must have to change. Dr. Fahim has made a good questions that what this file will automatically save in or not. So when you change something like that, if you want only normal irrigation, so you have to change the name of that files. Our original file name is data underscore soil, but new file where we want only normal data. So you have to change data underscore soil and dash normal. So you have to give some different name. So you remember that this file contain only normal irrigation, but your original file should be remain same. So you should not disturb original file. If you are making some changes in your data like that, so your original file should be remain same. Doctors, Dr. Sayed Adil Hussain Shah, you got that point? That's very
Yes, sir.
important.
Yes, sir. I have got the point. We will save the original file. Then we will for making another file. We have to put it the name also, only.
Yeah, well, you have to change a little bit so you
Uh,
understand that the
we will
original file
change
is
we will
yeah, you
change the
have
only.
yeah, you have to change the name so you remember that so your original file name is that and you what you want to change that is this name. So that's an important
Original
point.
file will not be interrupted.
Yeah, so R will interrupt it, so you will confuse that one data underscore soil and data underscore soil. And so you will use this name in future for that.
In
And
data file that contains two levels, both
yeah,
normal and skip. But in normal, we when we have will check the normal, we will change the name only.
yeah, that's a change only. And Mohit Ali, you got that point. That is very important point. Mohit Ali, you
Dr.
got that
Saab,
point.
Yes, I get this point.
Okay, good.
Yeah, it's clear.
You please explain it so other person can understand it if you.
Okay, now we are here doing subsetting of the data. I mean, we're choosing only one data. Here we choose normal. So we want to work only with the normal irrigation. So when we write our data, when we write the name, we should contain normal. So R will know that we only want to use the normal data for
Okay,
our
yes.
for the rest of the work.
Yeah, rest
And
of
the
the
same,
words. So yes, yes, Mohit, please proceed.
okay, and the same thing if you want to choose the another one, which is the skip one, we should write the name underscore skip after the name of the data, then subset, and we continue with the
Okay.
command.
That's good. So same like the Mohit Ali is saying that if we want only skip irrigations, so we have to data underscore soil and irrigation we want only skip, so we can do with this. So after it's clear, no, we have to move
So,
with
Dr. Saab, here,
yeah.
for example, the in subsetting, for example, we have two levels. Irrigation have two levels. So in
Okay,
subsetting, we do normal and skip. What if I want to add at this point another third level?
yeah.
So can I, in that way, I will have to change the command like how? For example, I'm adding one another level at this point. So I have to change.
Okay, you want to add some levels.
Yeah, yeah.
Oh yeah, you can add it in our below commands where you can bind row column, so you can add other levels. So you have other data set and you want here to add other level, so you can add it, no problem. So by the different functions you can add it. By this is row binding, so you can add it, no problem. You can add that other level also.
Okay.
Okay. No is the subsetting by value. I say that's our some data. So you can see that we have summary data underscore skip and water contents. So this is you can see that we have minimum value 28.10 and maximum value is 34.10. And I said that I checked the literature of this data, and I found that the value should be remain less than 34. Our data should not contain values more than 34. So, I said that I can do that with the command data underscore swal underscore skip on that's the file name you can give is. And we in scale and subsetting we are here using data underscore skip file, and I say I give command to R that water content should be less than 34. So by these commands I can give instructions to our software. Now we see again the summary commands, and but we will see that. And now you can see that R has removed all values above 34s and 34. So this you can see that now our value is 28 and 33 points. So through this you can removes odd values or values are not within the literature, and you can remove, and this is can also remove by normality data normality. But in some normal practices, if want you want to some simple graphics and you want that your value should not be more than this, so you can remove it by these commands. You can adjust it. And other command is we can do both things.
But Dr. Saab, here is one point.
Yeah,
For
yeah,
example, if we do it on the basis of some previous literature, for example, the previous literature said that when you use 2 irrigation level, so the water content doesn't exceed 34. Okay, so we
yeah,
don't
yeah,
want to change any, we don't want to change any value in the original file, I mean the Excel file or CLV file, but here
yeah.
we just put one command less than 34. So in this way, when we will draw the graph, so the maximum point will be below 34. Okay, but when we publish some paper, so they also require additional file. I mean, in additional file, we send them the original data and then all these R files. So they might find some discrepancies when they will, if there is some very genuine reviewer and they will look at the original data file and then what we have performed here in the R. So it might create some problems if they put on the original file and then they look at your graph. So they might know that we have made some changes. It will create some problem or not.
And no, you are right. And that's this is the problem. But that's a major data normality set. We make different data transformations in our data. So we will make our data normals through different models. So we should have to mention all things in our materials and method and where we are doing our statistical analysis. So we should mention everything. That's no problem. If you hide something from your reviewers, your editors, then it's problems. So you have to mention
Oh,
all
okay.
things
So
what you are doing.
data transformation with the original information mentioned is then okay.
Yeah, then it's okay. Mention you what you have did with your data. Then it's automatically reviewers and good editors will understand that what you have data transformations things you
Okay,
did you
okay,
in
okay.
your data. So you do not hide anything. So you are doing work honestly, so you mention all your things. So that's I am giving some points. So people made editing in data, or sometimes they delete these values, so they should know with the R's it's simple, so they find the things and delete and editing. So you do not do any editing and anything, so just you can skip something and mention in your paper and thesis what you have did with your data, so you do not hide anything from reviewers and editors. Then
Okay, okay.
yeah. Okay, then is the command that we can do with single command. We can select our category as irrigation in skip, and we can also do water content less than 34. So we can do all these things with single command. So you can do with this data subsetting. So this is also subsetting, and here you can both functions in one file. So you do not need to do double command as this is for your learning. So this is another commands where you can do both things in single line commands. So you can so so you can see that in single line commands So I did all that I do with 2 commands just. So this subsetting is clear. You all of you any questions in subsetting? So you can do or you can other operators also, logical operators and other operators you can use like this. These are available, but this is subsetting you can do in our analysis. You do not need to any deletions or any things in your original data. Your original data is file is saved, and you can do with this in our software with single line command just. So these are easiest
Sir,
ways.
I have the question.
Yes, Dr. Fine.
We have the maximum value 34. What about the minimum value? The minimum value is 28.10. If the minimum value is higher and we want our first minimum value like 29 or 30, then what should be the command?
Yeah, you can use same command, and you can say that here we mentioned that it should be less than, and where you can write more than 28. So you can just change the sign highers and lowers. So you want water content more than 28. So you can just change it. You can want higher content from 20 and not from lower than 28. So you can move. So your R will be show R that values. That's you can make changes, and other also logical operators and other more if and different functions are also available in ours, so you can use it. That's a subsetting, that's very important, and it save your times and so many things doing analysis in ours. So next thing is selection of row and columns. So we contain our data set data underscore soil. So we want that
Dr. Saab, did we use the summary command?
yeah.
Okay.
Summary, yeah. This is our whole data. You can see that we want data soil, we want first row and 7 number column values. We want specific selection of rows and column. Now we are going that points, and you can, and this all shows you that you are number 1 row, what is the values in number 1 and 7 number column. So you can see any column and any row numbers in your data. So this will also clear you that no, I show you. So here you can further it will clear you. This is data underscore, that's a bracket. Yeah, that's data underscore soil to data underscore. We want all rows, but we want this column 1 to 5 columns. So I want to remove all other columns. I needs only columns up to organic matters. So I needs column up to that. I want no other extra columns. So you can see that what I did. All my
So
data is present.
yeah.
Only 5 columns
Irrigation,
and all.
mulches, nitrogen. Yeah, only 5. Yes.
Only 5 columns are present, all other columns have deleted R. So I selected only that data set. I want to do analysis and graphic in only that parameters. So R has deleted. So you can select your which columns you want to work with you. So
So
you
how
not,
about rows? We can also delete the row in the same way.
yeah,
By the
same way you can
by the same
yeah,
command.
same command. So before comma, these are the rows, and after the comma, these are the columns. So which one you can also remove.
First number will be the first number in the bracket represent a row, and the
Yeah,
second represent column.
column. So you can delete or select any column or any row in your data set with this. And now in further, I show you, I want random column selections. I want this 1 column, 2 column, 3, 4, 5, 7, 9, and 10 column. I do not want others column. I want to delete other column. So you can see that. So you can see that R has randomly selected that column from us. So I want 1, 2, 3. I want 1, 2, 3, and 5, 7, 9, 10. So you can randomly select which column you want. I said that you do not to delete manual deletion. So through R, you can select different columns. You can select the column series or any column you can select with this. So can anybody explain these column selections? So what is the benefit of that commands? Can anybody explain it?
Maybe Dr. Saab, sometime we need is the specific interaction of the dependent and independent variable. For example, our data sheet have maybe more than 60 parameters.
Yeah.
But we need someday, for example, we need the correlation. For example, only two columns. Like how column one, for example, nitrogen can affect the yield. I don't want to analyze the whole thing at one time, but I want to have, or maybe sometime I don't need the, for example, the potassium, so I can mask it, and I can only analyze the whole data, the remaining column, and instant direction with the yield. So maybe it can, how to say,
Yeah.
we can
That's
have
your.
control on our data,
Yeah. You can do with only you what you have collected raw data, many things, many parrot you have collected, but you want some specific columns and specific parameter where you want to make your thesis graph or your statistical work you want to. Sometimes you other thing is sometimes you want to publish two paper from your data. You have long PhD data, 2 and 3 years data, and you want that I should have to publish data with these columns. I will publish another papers with these parameters. So you can do this. It's R. So your original file is saved, no deletion in your original files. So you do not confuse, and anything, any time you can see your raw data. And other thing, in first lecture I said you that the R will help you to understand your data. And you can see that how we can closely monitor our data, how we are seeing that what are our columns name and how we can remove or can these values, and these you can see that how it's are make easy to understand our data, which factors are, and these factors how many minimum and maximum summary range, what is the range of that parameters, how it's where from it's starting minimum, where is going maximum. So R help you to understand your data very closely, and any parameter you can watch summary of any single parameter, so you can see that. So R make your life easy and your data understanding more easy. So that's why. So what, Mohit Ali, you have learned from this selection of columns, why it's important? Mohit Ali, you are with us. Hello. Hello. Sayed Adil Hussain Shah Sahab, can you please?
Yes, sir.
What
By
is the
running
important?
commands, yes, by running commands, columns are adjusted according to it. If, which need columns are adjusted that according to the command.
Yes, we can easily selection of column make easy for us. So we do
Yes,
not, we have 60 parameters, 70 parameters. We are not confused with. We can only make a sheet with the parameters we are interested to do our statistical or graphic analysis.
yes, sir.
So our make life easy for us.
Sir, I have a confusion in 1 7 year data soil. 1 is the row, 7 is the column.
Mm. One 107 first of all, yes, 1 is the row and 7 is the column. I said in before comma that is the row, and after the comma that's our columns.
Then it is 851. What it is? 851 data size.
Yeah, this show that at one row and 7 column, this is value is present 8.51.
Achha.
This is R shows us. I want to see any values. I say that so you what is the value in a row, this row and this column. What is the value of that? So with this command, you can tell us that is the value in that row and in that columns. So single value you can put it out.
Okay.
Okay. Moidal is with us and an internet issue. Okay. Now we can simply deletion of column. This is we can also make a manage sign and we can delete 7 and 9 column from our data set. So this is manage sign and we can do this through this command. And you can see that 7 and 9 column has been deleted from the R's. Alpha 7. So in this, so manage sign, you can delete any columns. You want to delete any column. So just minus sign, negative signs, and delete it 7 and 9 columns. So you can delete it with easily. And then other thing is the columns.
If I want to delete a particular column in a particular row simultaneously, is there any command?
Please repeat your question.
If I want to delete a particular column and a particular row at the same time simultaneously, is there any command for that? For example, I want.
Yes, you can use this negative sign before commas. So it will delete that row if you want to delete it with this. And
for example, if I want to delete row 1 and column 9, so there will be only the same sign minus C because C is for column.
No, C is not column. C is a sequence. It shows sequence. It's 7, 9.
Okay, C is showing sequence.
Sequence. So it's not column. But before comma, I said that's a row. What you want with rows, and after comma, these are column. What you want to do with the columns. So you can do that.
Okay.
Next is the column names. And these are the my columns name, and you can see that these are the column organic matters underscore matters as water content water underscore content. I cannot write these names in my graphic. I needs the original name without any slash or underscore in my graphic. So I can change my name in R softwares without changing anything in my raw data files. So these are present at position 5 and 6. You can see that these are position 5 and 6. So I will write down its position 5 and 6, and then I will arrange them organic matters and water content. So you can see that.
Yes.
So you can see that the difference what R has did for us. So first these name were that organic underscore matters and water underscore content. Now R has changed that organic matter without slash and water contents without any slash. So you can change columns names with commands. So you do not need. So
okay, so we must change it, because if you don't change it, it will appear as a header on the graph.
Yeah, order of the graphs, and graph will not look good. So
Yeah.
so we can change when we are working with the graphic. So you can change the columns name with this command.
So this is a must or compulsory actually command.
Yeah, that's an important command. That's why I'm saying that this command will be helpful in your
You
graphic
have to
and
use it. You
Yeah,
have to.
that's yeah, this you have to endure. So you can, these are very helpful for your graphic. And then is the level, that's all important for graphic commands. Levels we have, you can see the control, plastic mulch, rice straw, and sawdust. These are our levels present. So I do not, these are control is present in one position, plastic one is present in two position, and rice straw in three position, and sawdust in four position. But in graphic, I do not want these positions. I want to change that, so my graphic should be look better. So I want control, then rice straw, then plastic mulch, and then sawdust. So I can rearrange levels of my treatment variables with this command. So I want to data underscore columns name mulches. This is my factors, and factor data underscore soil $sign mulches levels. This is again my factors, and now I will change here the arrangements. I want first control, then 3 is the rice straw mulch is second position, and in fourth position I then sawdust, and then last in the plastic. So I want this arrangement, so you can see what I did. Dr. Nasrullah sir, can you please explain this arrangements
Yeah.
of level?
For example, it is when we publish a paper. So, for example, we need the order. For example, if we have 5 flavors of a treatment, and for example, there is, for example, minimum level, middle level, and maximum level, or what you have explained here. So we want to rearrange this sequence. So without changing the original file, we will just put this command which you have shown here, and the sequence will change. For example, mulch will become the later one, and the other one, which was the later, that will become as the former one. So with this command, we can easily rearrange the, I mean, the factors, or the here are the treatment level or whatever. So we can change the sequence.
Yes, yes, that's important in graphics, and you deal some you want this should be present here, you see they are present here. So you can rearrange what you want. So that's an important one. Okay. That Moeed Ali is with us.
Yes, I want to ask about changing the names of the
Yeah.
columns. Like, I mean, the name. Okay. First, we do the analysis, and after that, the graphs. So changing the name before the graphs or after the graphs?
Yes.
I mean, after making the graphs or before making the graphs?
No, before making the graph, so name should be appear good on graphic. So it's you can see that it's a organic underscore matters, and reviewer editor will ask us what is mean underscore. So we should have to change before making graphic, so nobody can question us. So this is this is our raw data file. So when we will make graphics, so we should have to change it before making any graphics. So the correct names, sometimes we write short name. First time we write only water, or organic matters with short name in our raw data, but here we can write a full or complete name. So correct name should be appear on our graphic, so everybody can understand our graphic. So your graph should be complete, therefore we change it. Then I said the rearrangements of level of treatment. Sometimes you want your on accesses, your treatments or your levels should be appear in this way. So you can rearrange your all your level of treatment through this command. So it's you do not need to your files, and you can do with these commands in our softwares. So it's a quite easy here. So you can do this thing, especially in
So
graphic, this thing you are needed.
so for the analysis, it's okay to use the short name or the name with
Yeah, data analysis is okay.
it's
That's
okay.
not
But before
before.
displaying the graphs, I mean, before making the graphs, I have to change the name?
Yeah, you have to make write a correct name of that graph that should be appears. Sometimes you have write organic matter with small letter in your raw data, but you want your initial letter should be capital, so you have to change before making graph. So your so letters are your English. You want to correct spelling, sometimes not written on raw data, so you can correct it. Here's any mistake also.
Okay, it's clear now.
Okay, good. Oh, okay. So we will have to some more commands. Real addition of columns. I said that we can add any new column in our data set. Our data set is complete. Sometimes we make some calculation in our data. Sometimes we have to multiply something with our data with the columns. So we can do this mathematics also in our data. So for addition of columns, we need this command data underscore soil $ new on new column. What column name you want to give? Yes, here my data underscore organic matter. I want to multiply this column whole column with two times. Sometimes I see that I have made some calculation issue, and during my calculation organic matter I want to make it with some factors. So you can do without changing your raw data, you can do this in your R files. We can make a new columns here. So you can see that R has made new columns in for you and made all these calculations. So I have to proceed further. So then I will repeat this thing. So then is the binding of columns. I want to bind some columns with the. So I have data cell. I here I am making some new from original file to files. As Dr. Nasrullah question will be clear. I want 1 to 10 row and I want 1 to 5 columns. So I am making a new data set from our original file, which is data underscore soil. You can see that I have made these files, and now I want to make an other files. Data underscore soil is 2, data underscore soil is 3. I want as 1 to 10, and here I want C column. I want 1, 5, and 7 column. So you can see that. Yeah. Oh, I should. I have data underscore soil. So I have two files now. This has data underscores 2 and 3 files. So I have these. You can see that I have made two files in our original file. Our original file data underscore, I have made data underscore soil 2 and data underscore soil 3. And here you can see that these are the 5 columns in data set, and in data 3s I have also 5 and 6 and soil phosphorus. I want to bind this column with data 2. So you understand that I have made two files in data from our original file. One file contains 1 to 5 columns, 1 to 5 columns, and other file might contain the 7 number of phosphorus. I know this. I have two data set. I said in lecture also that I want this column should be bind with the data with the first the data underscore soil. So you can bind any column of other set in your original set or your now you can see that C bind is the function column binding. So data underscore soil, that's a here I in this file I want to bind column. I want to take column data underscore soil underscore phosphorus. This column I want to bind in two data set. So you can see that now your original new file has made which contain this column. So this column has been bind with our first data cell. So somebody may be confused with this. So I have two data set and I want to take column of second data set into first data set. So and then you can see data underscore soil 3 and soil phosphorus. And now I can change. This is a column number 6. So I can change that column name with this command. So you can see that it's correct. Can somebody explain it up to that?
Actually,
What
Dr. Saab, the screen is shared, but when you select, we can't see, it's not highlighted. That's why we are bit confused,
Okay, so I repeat that
the screen is
this is
shared, but when you are talking about some command, so you should highlight it so that we can see on the screen.
okay. Now you can see that my highlights.
Yeah.
Okay, so this is the binding of columns. I said that I make it two files. Data under I made these files from our original. We have data underscore soil, and I made 1 to 10 rows and 1 to 5 column. That is the question of your answer. You said that how we can select rows.
Yeah,
So
it's your
before columns before comma, that's 1 to 10 rows and 1 to 5 columns. So I made a new files from our original file that contain 1 to 10 rows and 1 to 5 columns only. And I made second files in R and data underscore soil 1 to 10 rows, 1 to 5 column, but I an additional 7 number columns. And you can see now that you can see that's column data underscore, that's highlighting sometime letters. Okay.
clear now.
Okay. So data underscore soil has 1 to 5 columns, and data underscore soil 3 has 6 column. So I want to bind data underscore column soil phosphorus with the data underscore soil 2 columns. So I can bind it with cbind commands, cbind function. So I can bind it with that cbind functions. So you can bind column of two different set into your original set. You can bind columns, and this command will be used in statistical analysis where we have made different mean table and statistical lettering table, and we want to bind two data set into one file. So you can bind. This is the main C binding function is you can bind column of two different data sets. So you will run these commands, you will then use to this command. That's a simple command. So I think you will be not problem with that. And last one is the today lesson is the binding of columns. Binding of rows, you can bind rows also. Like columns, you have two different set and you want to bind, you can bind rows of two different set. So again, I will make a new data set data underscore 7 data underscore so 1 into 10 columns, and then 1 into 10 rows and 1 into 5 columns, and other data files. So you can see that you can see on appearing your I have highlighted this. So you can see that I have this is the file. I made a new file data underscore 7. I run this file, and other again a data underscore 7 8. This is the again 11 to 20 rows, and then is the 1 into 5 columns. So this is second rows. So this screen is appearing to you. 1 minute. Yes, no, it's appearing. So you can see that this
So
is our
columns are same. You see 1 5 1 5, but we only want to change the rows.
rows change. Yeah, rows are changed. So we have made two different. So and
Okay, from 1 to 10 rows and then from 11 to 20.
11 to 20 rows. So we are row. So we can bind this data in first file. We can bind our second file. So row column should be same. You understand? I write this in my notes that when you binding of rows, then your column should be same. If columns are different, then this command will not run. So your column should be same, and you can bind different rows above and others. So you can see that. So this R has binding for us. So these two commands, column and row binding. So you can bind your columns and you can bind all your so this was the today lesson, and I have provided this command in my notes. You can practice in this. I will also share this script with you and data set. So you will practice it and you will hopefully do with this analysis. And if you have any problem, you can discuss me. So I repeat it again today lesson. So you have so So we summarize our lesson. So first of all, we have made working directory. So after making working directory, we have imported the files, and then I said you the data under frame. So data should be in row and column, and then we see the structures, and then in structures we have the structure should be comprises treatment variables and parameters. So in treatment variable, you have to convert them into structures, so into factors, so that your commands can be run and you can do statistical analysis and graphical analysis. Then it's the head functions command, where you can see your head all your six above rows of your data set, so you can confirm that the data you have imported is correct and right, and you can do with it. And then is the summary functions, and you can see the minimum and maximum values of your data. And then you can also show the summary of single parameters. And then is the column names. You can see that's what column names are your data have. Then is the levels. You can see that the which levels my factors have. You can see it in the R software. Then in subsetting you do not delete manually anything. You can select like in this data normal and skip irrigation. You can make different files in your. Then you can do subsetting by values. If you do not want that your value should be appears something below or something higher, so you can do with the subsetting by selection with this operators, logical operator. And then is the selection of columns. You can select columns of your wish. If you want to select some specific range of 1 to 5 column, you can select, and you can randomly select your column, and you can also delete any columns in your data. And then other is you can modify the name of your columns. You can modify the existing name in your raw data, so you can change it easily. And then is the rearrangement of levels of treatments. In level of treatment, if you want your graphic should be control and other patterns, so you can slang you rearrange in the R's. You can also bind, and you can make also new column in R software, and you can also bind your columns and your rows in R software. If you have two different set, you can do with it. Any question at this stage, please? So these are our 3 lessons. So these are very, very important lessons. So anyone has the question with it. So you will practice it and complete your all assignments of 3 days. Those are very important. And then your major things will be in next 2 day, where we will make tomorrow we'll make graphics, and last day we will do our statistical analysis. That's it. And that's all thing will summarize in coming 2 days. So all your learning is for that today, for your graphic and statistical analysis. And before that, you must clear this lesson, read our notes, read, you see practice all these things, so you are near to learn to make your graphics and do your statistical stable tables.
Thank you,
So
Dr.
I
Saab, for your detailed session. And actually, tomorrow we all should repeat yesterday lesson with practice. And today lesson is very extensive, so we need, I
yeah.
mean, whole day. We need tomorrow whole day to do practice on yesterday and tomorrow lesson. And maybe tomorrow night, maybe the lesson can be a little bit extended, because we will bring a lot of question to you tomorrow. Okay.
Okay, okay, that's a good things. I should that's I make these difficult simple thing for you. So three lessons are buildings for your graphic and your statistic analysis. Actually, you three things I in ours are in data science are three things I did discuss with you. Understanding of your data, making graphic, and doing statistical analysis. These are
Okay.
three things, and all softwares and all the three things, if you understand these three things, our trainings and our these 5 sessions will be fruitful for you. So questions are always welcome. We will also try to answer all your questions. So we are here. So thank you for all of
Thank
you.
you, Dr.
Anyone
Saab.
have a
Thank you,
question?
Dr.
So
Saab.
please. Anyone have a question? We are going to close our sessions. So be practice no thing. I made in I have write in text all these things that I discuss in my notes. So I your session is also, that's why grateful that we are providing for this training. This is our whole book. I and collected and I make these all commands and during my last 5 years. So I am this is my book which will be published soon in next year. So your session is
Thank you, Dr.
so
Saab.
I
And
don't I
we
do
have one
not
last
share with
request.
anyone. Yeah, I do not
I know.
share any these things with anyone. So, but I wish you learn a lot. So I share with you these all things.
Thank you very
So
much.
thank
And
you.
that's one last request.
Yeah.
This recording you should put maybe tomorrow, like at 8 or 9 o'clock, so that we may be able to listen one again to the whole. If we have some problem, then we can go back and listen to your recording, and then we can, correct the mistake. So request is that you should put in the OneDrive this recording as soon as possible, maybe early the morning.
Okay. Okay. That's okay. Well, it's take some time to upload. I also uploaded in last night, but it will be successfully uploaded in morning. So I will try my best to upload as soon as possible. Thank
Okay,
you.
okay, Dr. Saab. Thank you,
Thank
thank
you
you.
all of us.
Allah Hafiz.